I'm going to go through and answer any questions that you have on this homework. It's going to be completely up to y'all, okay? Y'all need to make sure you guys, the test is tomorrow, and I'm willing to answer any questions that you have. You have the key up on the board. Please ask me questions. I got 1, 2, 3 already. Yes. Number 5. So starting with problem number 5, let's take a look at what that is. While we wait on this to connect. Okay, on problem number 5, guys, when you have two terms, you have a flow chart. It tells you exactly what to do. With two terms, the two things you can do are GCF and difference of perfect squares. So the very first thing we look for is the GCF. Guys, what will go into 17a squared and 24ac? There is something. Guys, what goes into them? What do they have in common? A. They have an A in common. You cannot ignore the variables as a GCF. They both can divide by A. When you divide by A, that A is going to go out in front. That A is going to cancel here. The 17 doesn't have anything to reduce with. For the exponents, you've got a to the second and a to the first. When you subtract that, 2 minus 1 just leave you a to the first, which we write just as A. Minus 24, the A's would just cancel here, and you'd put the C on the end of it. So far, you good. Okay, guys, the next thing you look for is a difference of perfect squares. Guys, is 17 a perfect square? No, so you're done. That's it. That's all you can do. Do we write prime on this problem? Did we do something? Then we can't write prime. The only time you write prime is when you can't do one thing at all. Right? So that's your answer right there. You're done. Better? Okay. 2, yes. I'll get you next, Aiden. Number 3? Absolutely. On problem number 3. On problem number 3, we're looking at our 3 terms, which is our trinomials. We start with a GCF. Can everything in here divide by, I think it can. Want to go into 36, 24, and 4? Actually 4, yes. So divide by 4. That's going to make this 4 out in the front. That's going to leave you 9t squared minus 6t plus 1. So far, you okay? Okay. The next thing you look for when you have 3 terms is called a perfect square trinomial. You see if it fits the pattern. You have this first number. Is this a perfect square? The 9t squared. Yep. And then the 1 is also a perfect square. So you set up one set of parentheses, keeping the 4 out in front. You take the square root of this, which is going to be 3t. You take the square root of this, which is going to be 1. You take the sign from in front of the middle term, which is going to be minus, and the whole thing will be squared. You check it by doing this. 2, because it's always 2, times this first one, which is 3t, times this second one, which is negative 1. When you multiply 2 times 3t, that'd be 6t, and 6t times negative 1 would be negative 6t, which is what's in the middle here, so it checks. Did you see what you needed? Okay. What you got, Ava?
Number 6.
Number 6 is next. So, on number 6, we look at this problem. It's 3 terms. There is no GCF because there's no variables in common and there's no number in front. So the next thing we look for is a perfect square trinomial. So when we try to do a perfect square trinomial, guys, watch. Don't write this down. I'm just telling you ahead of time. Watch it first. Watch what happens. If I take the square root of q squared, that's going to put q at the front. If I take the square root of 36, that's going to put 6 at the back. The whole thing is going to be squared, and it's going to be a minus. The only problem is when I multiply 2 times q times negative 6, that does not give me negative 14q. Because of that, I have to go ahead and skip the shortcut, and just go straight to an easy diamond. See if I can get an easy diamond to work. I put 36 on top, I put negative 14 on the bottom. So far so good, just on the concept of setting up the easy diamond. Good. So guys, if the number on top is positive and the number on bottom is negative, everyone, guys, listen, what type of numbers are both the numbers going to be in your diamond? Negatives. They're both going to be negatives. So I'm looking for the numbers that multiply to give me 36. I'm just going to go through all the factors. 1 and 36, that's going to be too big. 2 and 18, that's going to still add up to too much. 3 doesn't go, well, 3 and 12 would be, nah, it's still 15. 4 and 9. 4 and 9 is 13. 5 doesn't go into it. 6 and 6? No. Guys, do any of those add up to 14? No. So what's the answer if I can't do anything to this problem? Prime. And I'll be honest with you, on a test when I'm taking it, when I'm making the key, if I get one that's prime, that's the problem I spend the absolute most time on. Because I'm trying to figure out, is there anything I can do to it? So what I do when I'm just telling you how I approach it. If I try a problem like this and I can't get an answer, I write prime, but I circle it, and I always come back to those at the very end and just make sure. Did I miss like a set of factors? Did I set up the signs wrong? Did I do something? Because how many, guys, am I going to put 8 primes on your test? So that's not a good thing to write down 8 times on your test. There'll be a few of them, 1, 2, 3 maybe. Anything past that, you're probably looking at, you need to be careful. Okay? Because I want to test everything. I don't want to just test prime. Okay, what else do we need to see? Yes, sir? Let me get everybody one time and then I'll come back around. Number 2? Absolutely. On problem number 2, and it can be anywhere on the worksheet, guys, just so we know. We got the key to the whole thing. On problem number 2, there's no GCF. That's the first thing we try. So on this one, we look for a perfect square trinomial. We can't do that because 6 is not a perfect square. So this is just going to be the hard diamonds, just old-fashioned hard diamonds. It's just the way we do it with our diamond, putting our numbers in our X. Here we go. The first number times the last number goes on top, which is 18. The middle number goes on the bottom, which is 11. And we look for 2 numbers that multiply to give us 18, but add to give you 11. Guys, you tell me what multiplies to give you 18, but adds to give you 11. 9 and 2. Perfect. So I set up 2 sets of parentheses. I put the 6b in the front without the square. And then I take the numbers from my diamond right here as plus 9 and plus 2. Now, what's the last step? Factoring out those GCFs. How do you do that? Guys, what number goes into 6 and 9? 3. Since it's a GCF just for that part, it just cancels out. So 6 divided by 3 would be 2b. 9 divided by 3 would be 3. On the other side, it'd be 6b plus 2. Because, oh, no, it wouldn't. Guys, what goes into that? Ooh, something goes into that one. I almost missed that. What goes into 6 and 2? 2. So that's going to divide and give you 3b plus 1. Ooh, I'm glad I caught myself. Okay, so look for those GCFs. Did you see what you needed along the way? What else, guys? Anywhere on the worksheet? Anywhere on the worksheet? Hold on, let me give everybody one chance and I'll come back around again. Yeah, absolutely.
For number 4,
yes.
After you get the answer, the only way you can simplify it from there is to find the square root.
Let's look. So GCF, what goes into that? Does 4 go into 56? Yeah, so we've got to divide by 4. So 4 goes out in front. That leaves you h squared minus, what's 54 divided by 4? 14. Okay. So we've done GCF. The only other thing for 2 terms is difference of perfect squares. Since this is not a perfect square right here, the 14, can't do anything else. You know you got to stop. Okay. Anybody else that hadn't done one yet? And then I'll go back around again. I don't mind. Okay. I told you first, and then I'll come back to you again. Okay. Guys, ask as many as you need to see. Please. I just want to give everybody a shot, and then we'll go back around again. Okay, I'll get it back to you. Yes? 27? Okay, problem number 27, guys. 27. Okay. First things first, is there a GCF? Can anything go into 9, 48, and 64? Try dividing 48 by 3. Is 48 divided by 3? 16. And 64 divided by 3? I don't think it does. No, so there's no GCFs. So no GCF. So then we go to our 3 terms, our 3 choices when we do 3 terms. Perfect square trinomial, hard diamond, easy diamond. Oh, actually, this is a perfect square. This is a perfect square. So let's see if we can make this work. The square root of 9x squared would be 3x. The square root of 64y squared is going to be 8y. The sign from in front of the second number is going to be plus, and the whole thing would be squared. Okay, when I multiply 2 times 3x times 8y, I'm just always 2 times these things that are in here. Let's see, 2 times 3 would be 6. 6 times 8 would be 48, and the xy goes on the end. So that's it. No work. Okay, but you got to recognize that it's a perfect square trinomial. Otherwise, you're doing a really huge diamond, and you don't want to do that. That's why, remember how I talked about it? It's not that you can't do it. It's that it just saves you a drastic amount of time. Okay, yeah. 16? Absolutely. 16 will be our next one. Is it? Okay. Factor by grouping, guys. 4 terms immediately. There's nothing. GCF and then factor by grouping. There's nothing that goes into all of them, so we group the first 2. We group the second 2. What goes into the first 2? M. Put it out in front, because, guys, this is factor by grouping. You keep that GCF out in front. So it's going to leave you x plus y. Factor out the GCF. Oh, and you can show the divide by m if it helps you to cancel that out. Like, please feel free to put that under there so you can see that. And then on the second one, what do they have in common? N. N. So that puts that out in front and it leaves you x plus y. And do you see that you got the common thing now? The x plus y on both of them. So that goes out in front. What's left over, the m plus n goes in the other one. Looked like you saw it as soon as I started getting the process there. Okay. What else, guys? Yes, sir? 23? Absolutely. Got it? Okay. 23 is our next one. Okay. I don't see a GCF. So then we go to perfect squares, which this is not a perfect square because we can't do that. So we go to a hard diamond. So if we do a hard diamond, oh, guys, remember what I talked to about this? 2 times 2 is 4. The middle number is 5. What 2 numbers work? 4 and 1. When 1 is one of the numbers, it's missed a lot on the test. It seems like it'd be easy, but people get bogged down in the 2 times 2 and they can't figure out the 4 times 1. So you write the 2x at the front of each one of your parentheses. You write the plus 4 and the plus 1 at the back of each one. Okay. Take out the GCF here. That's going to leave you x plus 4 divided by 2 be 2. And then the 2x plus 1 doesn't have anything else it can go with. Does it matter which parentheses comes first? No. You could have put 1, 4 and yours would be backwards. Doesn't matter. Do you see what you needed? Yeah. 26? Absolutely. So first things first. We're going to look for a GCF, but 25 can only divide by 1, 5, and 25. And those don't go into 9, so you don't have a GCF. The second thing is this can't be a perfect square trinomial because perfect square trinomials do not have a minus in front of the last term. So immediately perfect square trinomials out. Then you're going to go to this hard diamond. And this hard diamond, grab your calculator. What's 9 times 25? And it's got to be a negative because negative 225, it's negative 25. Okay, and on the bottom it'd be negative 30. Okay, you're going to have to list out the factors for 225, guys. It's just going to be calculator work. Grab your calculators and start giving me these numbers. Now, I know the first pair is just going to be 1 and 225. 2 doesn't go in. Try 225 divided by 3. So 3 and 75, so that's 78, or it's going to be like 72 apart. Still not close enough. Let's try 4. I don't think it works, but try it. Doesn't. 5 goes in there. 45. 5 and 45 are 40 apart if one's negative and one's positive. So still not close enough. Try 6. No. 7. I'm guessing a lot of these don't work. 8. No. 9. 9 and 25. Okay, listen. 9 and 25. Okay. 9 and 25. When you do that, you can see if I put 9, let's say 25 here, 9 here, is that going to add up to 30? Okay, I'm just getting further and further. I'm going to make it smaller and smaller and smaller as I go down. So we didn't skip any. There aren't any in between here. So because of that, the difference between these is 40. The difference between these is going to be what? 14? No, 60. So we jump from 40 to 16. There's no way to get it to equal or add up to 30. Because of that, guys, I can't do anything in this problem. Because I can't do anything in this problem, what do we write down? Prime. And again, I would say that would be one I'd try, and then I'd come back to and look at my factors again. Did I miss a factor? Did I do something wrong? That would be the last problem I did on my test, to make sure prime problems should be like checked before you turn in. There's one exception, guys. If you have a problem like number 21, how do I know immediately this one's prime? No GCF and what else? Guys, you should be able to tell me this immediately. Look at number 21. Why is 21 prime? It's plus. Guys, the only two things you can do when you have two terms is GCF and difference of perfect squares. Is this a difference? No, this is a sum. Because of that, this is prime. This one, however, is a difference of perfect squares, which means it would factor into two sets of parentheses, 1 plus, 1 minus. Square root of b squared would be b, and the square root of 25 would be 5. Do you see the difference between those? Everybody's good on the reason, the prime. That wasn't your direct question, yours was the other, but the idea behind prime. Anybody else? What else? You sure? Okay, guys. What day are we taking our test? Tomorrow. And